All right, example 3. We're getting a little bit more involved and a little bit more technical with this, because in this particular problem, we're taking the derivative of tangent of sine squared of 5x. So what this is, technically speaking, is 4 functions being composed here. So we're not going to do the usual approach of writing the outside and the inside functions. We're just going to try to do this like using the intuition of chaining things together, because I think that that's going to be a little bit more helpful than writing a bunch of scratch work and losing sight of the original problem. So the first thing, of course, we want to do is whenever you see a power on a trig function, convert that to a big power around everything involving that trig function. So let me just rewrite this as tangent of sine of 5x squared on the inside of this tangent here. So basically I just converted this loveliness so that it had a power of 2 on it instead of just having the 2 on the sine. Just changed notation. Nothing weird going on there. You've done it probably 1,000 times by now. Okay. So now we have, working from the outside or from the inside out, innermost function is 5x. That's inside all of this other stuff. The next outermost function is going to be the sine of 5x, or just the sine if you like. Then the next outermost function is the squared bit, and then the final function is the tangent. So we have to work, when using the chain rule, we have to work from the outside in. So our first step is to work with the big stuff first, the red function, our tangent. So derive tangent. What is the derivative of tangent? Hopefully you remember, it's going to be secant squared of x, or in this case, secant squared of everything that's inside the original tangent, all the purple underlined stuff. So this is going to be sine of 5x squared, and that's the inside of that. Okay? So now our idea is then to multiply by the derivative of this purple underlined thing. Okay? The new inside or the new outside function. So the new outside function in this case is the squared. Not the sine, the squared. That's happening before the sine. So this 2 is going to get moved down in front. So the idea is deriving this. So we're going to move this 2 down in front, subtract 1 from the exponent. That's all we're doing. So I'll do this in blue. So this gives us 2 times sine of 5x to the first power. All I did was I took the 2 inside on the purple thing, moved it down in front, subtracted 1 from the exponent, and copy-pasted the inside of the purple underline function. Okay? That's all I did. And now the idea is to derive this lovely thing here, the sine of 5x. So the outside function is sine, so we have to derive that. We multiply by cosine of 5x. And then we multiply by the derivative of the inside of the cosine. So it gives us 5. Okay? So that's that. That's completely derived out. We derive the tangent first, and then we derive the squared stuff, and then we derive the sine stuff, then we derived the 5x. And we just multiplied it all together. Okay? So that's that. If you wanted to combine some of your numbers here, you want to multiply this stuff out, be my guest. You can definitely do that. But I think for the sake of elucidation, we're going to keep things as they are right now. Okay? So this problem is done.